Okay, hi guys, so we'll be continuing from the previous lecture wherein we were discussing the phase equilibrium of water. So let's get started with this lecture. So next is when you talk about melting point or freezing point, first let me write down the heading first. Melting point or freezing point. This is the temperature at which the rate of melting of ice is equals to the rate of freezing of liquid water. So temperature at which rate of melting of ice is equal to rate of freezing of liquid water. Okay. And we can say that at melting point both phases are at equilibrium, means the water liquid phase and the solid phase, both phases are at equilibrium. And next point is when pressure increases in phase equilibrium shifts towards less specific volume. Okay, so when pressure increases in phase equilibrium, equilibrium shifts towards less specific volume. Specific volume is nothing but V upon M. This is specific volume. Okay, so we can write that we can directly see via the help of a graph that suppose we have a graph like this. Okay, so as pressure increases, let me first write down the graph variables P and T here, and this is the graph, this is the curve, something like this. Okay, this is the phase equilibrium of water, this is liquid, solid and gas. Okay, so let's suppose we are at P1. Okay, and the temperature here was T1. Now when we increase the pressure, what actually happens is this is T2. So we can write that as the pressure increases, the melting point decreases. Melting point of water decreases. Why? Because initially melting point is just the temperature value. Okay, melting point is nothing but the temperature at which the melting occurs or the freezing of water occurs, liquid water occurs. So this was the initial melting point. Melting point initial was T1. Now as we increase the pressure, melting point final was T2, means T2 is the temperature at which the solid and liquid phases of water are at equilibrium. Okay, so we can see that T2 is lesser than T1. This implies melting point decreases as pressure increases. Okay, and what about the boiling point? So if we talk about the boiling point in this via the same graph, we can write it that this was our graph. Okay, this is pressure, this is temperature, this is the graph, Okay, so initially let's say we were at P1 temperature and T1 P1 pressure and T1 temperature. Now we increase the pressure to, let's say, P2 pressure. Now at P2 pressure, what will happen is we would have T2 temperature. Okay, boiling point initial was nothing but the temperature at which liquid and gaseous phase occur at the same point or in equilibrium. So boiling point initial was T1 and boiling point final would be T2, and as T2 is greater than T1, this implies that boiling point increases as pressure increases. Okay, so when we talk about what are the favorable, so we are done with this two graphs. Now the next point I'm trying to say is, when we talk about what are the favorable conditions for the melting of ice, so what would the favorable conditions of melting of ice? It would be simply high pressure and high temperature. And why is this the case? We have just looked at in the graph. I'll again explain that what are the favorable conditions for melting of ice. This is obviously that we know that melting of ice is a endothermic process. First let us write high temperature, then we'll look at commenting on the high or low pressure thing. So we are damn sure that it definitely needs high temperature. Why? As it is a endothermic process. Okay, now what happens is, obviously let's look that in this graph, that as we have high temperature here, so let's say we have temperature, this is our temperature, T is the temperature here. So for this temperature to occur, so we want the melting of ice. So melting of ice, which means that we are talking about the phase of liquid in phase of water in phase of water in liquid phase, means water existing in liquid phase. So suppose this is the temperature for the endothermic process. Now, so for now, if we take pressure something like here, then it still would be a solid phase. If we take somewhat here, then it still would be a means if we take something here, then it still would be a another solid phase. So for this water to be successfully in liquid phase, we need high temperature, so that the meeting point of the pressure and temperature gets meet in the liquid phase of water, so that here we need this pressure. Okay, if we have high pressure and high temperature conditions, then the water will exist in liquid phase, because all this area between this line and this curve belongs to the liquid phase of water. Hence, if we have high temperature and high pressure, what will we have is the meeting point of both the lines or both the axes would be in liquid phase. Hence, we need high temperature and high pressure. So we need high temperature and high pressure. Okay, so with this we come to the end of this lecture. In the next lecture, we'll be seeing some more concepts on the phase equilibrium. Then we'll be starting on vapor pressure. So till then, good luck and goodbye.